Hi, this is the first video that I'm gonna make. I'm making to welcome you first to college algebra, and also I hope you're doing well, at least okay, with all the changes caused by this coronavirus. But I think I'm sure we can make this and finish this course. I know we are 1 week late to start, but that's okay. I think we can do this. I had a week actually at the end in the calendar that there was nothing to do, just left it empty in case. So looks like we have to use that. So I modified the calendar. It should be matching what we do this semester. So what I'm gonna do, I'm gonna make some videos on most probably on all the chapters, and in some chapters I might have more than one videos, but there are going to be videos that I'm going to link in course content in Blackboard, and this is the first one on chapter 2. So let's just start. I'm going to go over some basic ideas in algebra, and then we're going to go to Newton Alto and do some of the assignments together to make sure you know how to do it. And so let me first get rid of my video. I don't think we need that. It's just gonna take part of the screen. All right, so let's get back. So there are very basic ideas in college algebra that we need to understand before we start doing some work. So the first is interval notation. So what is that? Well, in mathematics, when we have an answer, usually the answer is either a number or a bunch of numbers or a set of numbers. So we have to represent that by using interval notation. So let's talk about that. So for example, if you're interested in, if you have numbers from let's say on the number line, so let's say you have let's say you want to represent numbers from 2 to 3. Let me get the white colors I can write on this screen. So suppose you have numbers from, let's say, 2 to 8. So you want all the numbers from 2 to 8. You want to include 2 and include 8. So how do you represent that? Well, one way is to just draw it on the number line like this. But another way to do this is to use the interval notation, which basically you build using either parentheses or bracket. So if I want to represent these two numbers using interval notation, I would write bracket 2, 8 and bracket. So bracket indicates that the number is included, and over here also bracket indicates that the number is included. And this notation means all numbers from 2 to 8. And I don't mean just integers, 2, 3, 4, 5, 6, 7, 8. I mean all real numbers, 2.01, 2.9, 2.00001, all of them. So there are infinite number of numbers in this interval. So that's what we mean when we say bracket 2, 8 bracket. It means the numbers between 2 and 8, including 2 and 8. All right, so here are a bunch of examples of different, these are different examples that you see. Get my microphone situated correctly. All right, got that. So we have So for example, this first one, so this first one right here, let me get the color back to maybe red. Okay, so this first one means all numbers from A to B, not including A and B, because we use parentheses there. So a number line, it means all the numbers between A and B, but not including A and B. And this one right here means all numbers from A to B, not including B, but including A. And as you see here is filled in and here is empty. Now, here is A not included, but B is included. Here, A and B are both included. Now, with another notation that is a little fancier mathematically, it's called set notation or set builder notation. And that is, we use curly brackets for that. So we put curly brackets and we put some variable, doesn't matter what, usually x. So it means x such that, and we put the condition after that. For example, this first one says all number x such that x is between A and B. So x is greater than A, but is less than B. That's exactly the same thing that we want on the first one. So we don't want A and B. If we want A, then we include the equal sign. If we want B, we include the equal sign. If we want both an A and B, we include equal signs. Okay, so that's set notation. Here are more examples. What if I want all the numbers to the left of B, not including B? Well, then we put parentheses and we put the end points in the parentheses. On the right hand side, the end point is B, so we put B there. And on the left hand side, well, there is no end, so we put infinity, and since it's to the left, it's negative infinity. And then we put parentheses for B, and we always use parentheses for infinity. And same is here. In this case, we want B. Here we want A and all the numbers to the right of it. Here we want A, including A and all the numbers to the right of it. And this last one, well, looks like we want every number on the number line. So within our notation, we just write negative infinity to infinity. It means all real numbers. Now this blackboard kind of font R, which is kind of sometimes written like this, that means all real numbers, the set of real numbers. That's the name of the set of real numbers. All right, so that's interval notation. And here are some more examples. I think it's clear how to do this. All right, so now sometimes in math, we are interested in combining two sets of numbers. For example, suppose we have a set of numbers 1, 2, 3. Here's a set of number A, and then we have another set of number maybe 3, 4, and 5. So we can combine these two sets by two different operations. One of them is called intersection, which is represented by this upside down kind of U. That's intersection symbol. So A intersect B. That's how you read it. A intersect B. That means we are interested in a set that has members such that the members of that set have to be a member of A and a member of B. So for example, here in our example, A intersect B will be, well, 1 is not in B, 2 is not in B, 3 is in B, so we put 3 and we're done. So we start with one set and then go through the members and see if we see them in B. If we see them in B, we put them in the set A intersect B. So that's the set A intersect B. Now, A or B, or A union B, is a set such that the members of the set are either a member of A or a member of B. It could be also both. We just don't write it twice. So if I want to write A or B here, A or, sometimes it's called or, this one sometimes is called or, and this one is called and. So A or B, or A union B, is going to be, in our example, well, 1 is good, 1, 2, and 3, they're members of A, so they satisfy their condition. Now 3 is in B, but is already listed here. 4 is not listed, 5 is not listed, so I'm going to list it. So that's A union B. That's what it is. Now, so here's an example again, and we got that. Now, sometimes instead of having discrete values like these, sets have infinite number of values. For example, this set right here, remember, is all numbers from -5 to 3, including -5, but not including 3. So that means that this set has infinite number of numbers in it. Now here's another set which has all numbers after 1. So what would A intersect B be? What's A intersect B? Well, here is set A. Notice that it goes from -5 to 3, not including 3. All of that. And then set B is from 1 to infinity. So it goes forever this way. Starts from 1 and goes forever this way. Now if you notice, these two sets, what do they have in common? Well, what they have in common is all of these numbers right here. So A intersect B would be all numbers from 1 to 3, but 1 is not included because 1 is here but is not here. And 3 is not included because 3 is here, right, but is not here. It's empty right there. So let me erase all that. So if we want to do A intersect B, we have to pick these numbers. So A intersect B would be from numbers from 1 to 3, not including 1 or 3. Now, what is A union B? Well, A union B will be all of these numbers up to here and all of these numbers together. So is 1 included? Yes, because 1 is not here, but is here. Is 3 included? Yes, because it's here, but it's not here. Now remember, the condition is that it has to be only in one of them or both. So both of these numbers qualify to be a member, 1 and 3. So that means basically all numbers from -5, and we come over here, we get to 1. Is 1 included? Yes. Okay, we get to 3. Is 3 included? Yes. And all the numbers after that right here, all of these are included. So that means all numbers from -5 all the way to infinity are included. All right, so we want to write this in terms of interval notation. So the first one says all numbers less than or equal to -2, or all numbers greater than or equal to 2. So with interval notation, we're going to have two intervals, right? We're going to have all numbers from -infinity to -2, which is this one, including -2, and all numbers after 2, including 2, which is that one. Now number 2 says x could be any number except for 3. So that means we can highlight the whole number line except for 3. And so with union with interval notation, we're going to have to use 2 intervals again. So we'll be from negative infinity to 3, union from 3 to infinity. What about this one here? Well, it says x cannot be negative 3 and cannot be positive 3. So that means we have to break the number line into 3 parts. All the numbers up to negative 3, all the numbers between negative 3 and 3, and all the numbers after 3. So that would be all the numbers before negative 3, not including 3, union all the numbers between negative 3 and 3, and union all the numbers after 3. And this last one is a little tricky maybe. The first part is easy. That's just x is between negative 1 and 3. All the numbers. The negative 1 is not included, but 3 is included. And then we have to add 5 to it, but 5 is just a single number. So we have to put it in a set notation like this, so we can combine it with the union symbol. It is wrong to put union just 5, because 5 is a number, and this union operation only applies to sets of numbers. You can't union a number with a set. You can only union two sets. All right. So one of the most important concepts in algebra is Cartesian coordinate plane. Cartesian it's named after Descartes, but his name is Descartes. Why do they call it Cartesian? Is because in Greek, his name is Cartesius or something like that. So Cartesian comes from that. All right. So to draw algebraic things using geometry, it's what Cartesian coordinate plane would do for us. So basically what we want to do, we want to unite algebra and geometry. And Cartesian coordinate plane does that. So imagine 2 real number lines crossing at a right angle at 0 right here. So you have 2 number lines. We have this number line and we have the other number line. And they're perpendicular. That means they will make a 90-degree angle. So the horizontal number line usually is called x, and the vertical number line is called y. And what we can do with this is just amazing, what we can do with this. So, for example, consider the point P. So, this point P could be represented by 2 numbers. The distance from this line, which is 2, and the distance from this line, which is 4. So we can represent it by 2 numbers, 2 and 4. But since this is below the x-axis, we're going to make these numbers negative if they're below the x-axis, and we're going to make these numbers negative if they are to the left of the y-axis. So these are negative numbers and these are positive numbers on the horizontal axis, and then positive and negative on the vertical axis. So any point can be represented by 2 numbers indicating the distance from these 2 lines and also the direction of the distance, whether they're below or above. So here, this point is at 2, -4. So always we put the x coordinate first and then the y coordinate. So that's why we call this an ordered pair of numbers. Okay, so we describe the point P using only the ordered pair 2, -4. So in mathematics, it's kind of maybe confusing when you write -2, 4. Well, this also means all numbers from -2 to 4 not including negative 2 and 4. So the context of the problem determines whether we are talking about interval or we are talking about a point. So in this case, this is obviously a point. Okay, notice that the order again matters. So if we put negative 4, 2, then we get completely different point, way over there. So to plot a point, let's say you want to plot negative 4, 2. Where is negative 4, 2? We start from the origin. The first number tells us to go right or left. If it's negative, we go left. If it's positive, we go right. So since it's negative and it's 4 units, we have to go left 4 units. And then the second number tells us we go up or down and how many units. If it's positive, we go up. If it's negative, we go down. So this is basically instructions to go left 4 units and go up 2 units. And here's the point. And this is a unique point. No other point has these coordinates. That's a unique pair of coordinates for just that point. All right, so 2 points represent the same point in the plane, then basically x and a y have to be the same. 2 ordered pairs cannot be equal if these are not equal. It's an obvious thing, but that's what it is. If we have an ordered pair and the y part of it is 0, if this is 0, so that means this point is on the x-axis, right? So here is the coordinate plane. If all the points on the x-axis, they have y-coordinate 0. And this tells us that all the points on the y-axis have y-coordinate 0. I mean x-coordinate 0. For example, this one could be 3, so it's 0, 3. Now this could be, let's make it 2. This is 3, so that means that point is actually 3, 0. And the origin is the point 0, 0. It is the only point common to both axes. So they intersect only at one point, and that's 0, 0. Plot the points. Well, to plot 5, 8, we have to go to the origin and go right 5, right? And go, I went one too many, and then go up 8. Negative 5 over 2 and 3. Now negative 5 over 2 is 2.5, so we have to go to 2.5 left and up 3. Negative 5.8, negative 3. Go negative 5.8 is about right there, and negative 5.8 and negative, oops, I got out. I didn't want to get out, but let's get back. There you go. Okay, so negative 5.8 and 3, I was doing negative 5.8 and negative 3, 4.5 and negative 1, 4.5 and negative 1, 5 and 0, well 5 and 0 is right there, 0, 5, so don't go left or right and go up 5. And negative 7, 0, go left negative 7, but don't go up or down, so stay right there. 0, negative 9, 0, don't go left or right and go down 9. 0, 0 is this the origin. Okay? All right, now the coordinate plane is divided into 4 quadrant. Of course, quattro means 4, and dividing into something into 4 parts, each of them is a quadrant. So we got quadrant number 1. In this quadrant, x and y numbers are all they're both positive. And then we have quadrant number 2, when the x is negative and y is positive. And we have quadrant number 3, x is negative, y is negative. And then quadrant number 4, x is positive, y is negative. You don't have to memorize these. You can just imagine this. It's very easy to imagine, right? Remember, x is the horizontal number and the y is the vertical number. So for example, 1, 2 is in first quadrant. 1, 2 is right there. And negative 1, 2 is in the second quadrant. Negative 1, negative 2, negative 1, negative 2 is right here, is in the third quadrant, and so forth. If a point other than the origin happens to lie on the axes, we typically refer to that point as lying on the positive or negative axis, or on the positive or negative y-axis. So there are some points that are not exactly on in any quadrant, like this one or this one or this one or this one. So this point is on the positive x-axis, this is on the positive y-axis, negative x-axis, and this is on negative y-axis. Okay. Well, the idea of symmetry is very important in all sciences. So there are 3 of them that we can actually talk about in coordinate plane. It's very easy to think of them. And that's symmetry with respect to x-axis. For example, if we have a point here, let's say it's 2 and 3, then, so this is 3 and this is 2, then a point that is symmetric with respect to x-axis is just you draw a vertical to the x-axis, go to the other side, and you see that point is symmetric with respect to x-axis. So what's the coordinate of that point that is symmetric? Well, that would be 2, negative 3, right? So if the y coordinates are negative, see, that's a negative here. So that's 2, negative 3, that point. So if the y's are opposites, then they're symmetric with respect to x-axis. If the x's are opposite, see, this one is negative 2, 3. So that point and this point are symmetric with respect to y-axis. And this point right here, which has x and a y both negative, would be negative 2, negative 3. That point is symmetric with respect to the origin. So symmetry with respect to x-axis, with respect to y-axis, and with respect to the origin. That's what they are. So let's look at some example. For example, for the point negative 3, negative 7, identify the quadrant or axis on which the point lies. So negative 3, 7, negative 3, negative 7 is over here. So it is in the third quadrant, right? Is it on any axis? No, it's on the third quadrant. And I let you do this. You can stop the video here and do the rest of them and see if you find out where they are. Well, this one I do for you. Pi is like 3.4, which is about 3.14. It's about right there. And the square root of 10 is like 3 point something. So it's about right there. So that is in quadrant 1. I'll let you do the rest of this. All right. Let me go over it one more time so you can actually see it. Go over it slowly. And this one. And this one. All right. Okay, so let's moving on. We're going to talk about distance in the plane. So to understand how to find the distance between 2 points in algebra, we are going to put those 2 points in the ordered pair forms in coordinate plane. So you see, here's the first point and here's the second point. So we're going to call this xy. Xy are the coordinates, of course. Now if you call this x1, y1, you can't call the other one x1, y1, so you have to call it something else. So the way we do it is we put a subscript. So x sub 0, x sub 1, x sub 2, x sub 3. So these are the way. This is how we name these points, so we don't get confused. So now we know we have 2 points, so we want to find the distance between them. Now if you make a right triangle like this in the coordinate plane, you can see that the distance between those two is basically this hypotenuse. And in geometry we know in a right triangle, the hypotenuse squared equals to the leg squared plus the other leg squared, right? So the distance between 2 points is represented by this distance formula right here. So this distance right here is basically x1, which is this distance here, that's x1, and then minus this distance right here, which is x sub 0. So that's the distance between x1 and x sub 0. That's what that is. And looks like I made some mess there. Okay, there we go. So that distance would be x1 minus x sub 0, and the distance over here is y1 minus y sub 0. So basically means if you call this a and b, then d squared equals to a squared plus b squared, and that is basically the Pythagorean identity. So the distance squared equals to a squared plus b squared, and a is nothing but x1 minus x sub 0, and b is y1 minus y sub 0. So and take the square root of both sides and we get the distance formula. So that is the distance formula right there. So example, let's find and simplify the distance between -2, 3 and 1, -3. Well, we substitute these numbers. If you call this x1, let's say call this x sub 0, y sub 0, call this x1 and y1, then we can subtract. So x1 minus -2 is 1 minus -2, and then squared, and then plus -3 minus 3, -3 minus 3, and square them. So we get square root of 9 plus 36, which is 45, and square root of 45 is just the square root of 9 times 5, or the square root of 9 times the square root of 5, and the square root of 9 is 3, so it's 3 square root of 5. So the distance is 3 square root of 5. And if you go back and look at this distance here, that means the distance right here is 3 square root of 5. All right, it says find all the points with x coordinate 1, which are 4 units from the point 3, 2. How do we find all of them? For all points with x coordinate 1, this x coordinate 1, which are 4 units from the point 3, 2. So we can think of that point is 1, x coordinate is always 1, and the y coordinate we don't know, but the y coordinate has to be 4 units from the point 3, 2. So we're going to basically take this point and write the distance between that point and that point. So think of one of them as x sub 0, y sub 0, and the other one is x1, y1. So if you think of this of x sub 0, y sub 0, and think of 1 and y as x1, y1, then you can subtract them. So x1 minus x sub 0 would be 1 minus 3, which is right there. And then y1 minus y sub 0 would be y minus 2 squared. And that is an equation which has a radical in it. Now we're going to talk about radical equations, but basically to get rid of the square, you have to square it, right? So if you square both sides here, we can get rid of that square root. So 4 squared is 16, and this is square root of something, whatever it is here. When you square it, that thing comes out, right? So we just get inside whatever that is. And it's 4 plus 1 minus 2 is y minus 2 squared. And now we move the 4 to the other side and subtract it from 16. We get 12. And then you take a square root of both sides, basically. You can write it this way if you're more familiar with having the variable on the left. That's fine. But that's what that is. So y minus 2 equals to y minus 2 squared equals to 12. So now we take a square root of both sides, and we have y minus 2 equals to plus and minus the square root of 12. And we add 2 to both sides. Of course, again, square root of 12 is the square root of 4 times 3, which is square root of 4 times square root of 3. But square root of 4 is 2, so that's 2 square root of 3. So that's 2 square root of 3, and then plus and minus, so we add 2 to both sides and we get that. So the points that have x coordinate 1, and there are 4 units from this point, are these 2 points. 2 plus 2 square root of 3 and 2 minus the square root of 2 square root of 3. The y coordinates are this, but the x coordinate is 1, of course. And these are the 2 points, right? So you see, that's one of them. And so the x coordinates is 1, right? That's the x coordinate is 1. And y, we don't know what that is. Well, the distance from it to this is 4 units. Now, where is the other one? Well, the other one is 1 and 2 plus 2 square root of 3. 2 square root of 3 is about 3 point something, so that's 5 point something. So the other one is way over here, right? That's one of them, and the other one is way over there. Those are the 2 points they have x coordinate 1, and there are 4 units from this point. See, this distance is 4 units. So we found both of them. All right, so we could also find a midpoint between 2 points. To find a midpoint, all we have to do is find a midway for the x coordinates. So what's the midway for the x coordinates? Well, it would be the middle of the 2 x's, right? And for the y coordinate would be middle of the 2 y's, right? So basically, to find the midpoint, the x coordinate of the midpoint is going to be just add the 2 x's and divide by 2. And the y coordinate would be just add the y's and divide by 2. So that's very easy to do. So what's the midpoint here? Well, the midpoint would be negative 2 plus 1 divided by 2, and 3 plus negative 3 divided by 2, which is basically 1/2, negative 1/2 and 0, right? All right, so let's talk about linear functions. Now that we got some basic stuff under control, let's talk about linear function. So now, in order to make sense of a line in algebra, we have to make sense of what we mean by steepness. So steepness is basically difference between this line and this line and this line and this line. So these are different in a way that their steepness is different. Now, we need a number to represent that steepness. Now, to do that, we're going to talk about something called slope of a line. So what is the slope of a line? Well, slope of a line is a number that represents the steepness of the line. How can we determine that? Well, we can determine that by a number that is a ratio of the change in y coordinates over the change in x coordinates. So basically, we're going to think about how do we go from, when we go from y sub 0 to y sub 1, how much does y change? And when we go to x sub 0 to x sub 1, how much does x change? So if we go from this point to this point, how are the y and the x coordinate changing? Well, that is kind of a measure of that. It's a ratio of change in y over change in x. So now, obviously, if the x's are the same, then the slope is not defined, because then if these two are the same, we get a 0 in the denominator. So the slope wouldn't be defined, because you can't divide a number by 0 in math. So let's talk about some examples. The letter m is used in mathematics to represent slope. So slope also, of course, it means a rate, is a rate of change, is a rate of change in y over change in x. So when we say, for example, the slope of 1 over 2, it means if you start from any point on that line, if you go right 2, then you have to go up 1. If you go right 2, and you have to go up 1. So 1 in the numerator means change in y and is positive, that means it's up. And then change in x is also positive, that means it's to the right. So when we say slope is 1 over 2, that means for every 2 units of change in the x, the y goes up 1 unit. So to find the slope, that's the formula we use, right? So remember, we have to name these. You call this x1, y1 if you want to. You could call this x2, y2. So the slope is y2 minus y1 over x2 minus x1. And so in this case, 4 minus 0 over 2 minus 0. So the slope is 2. You could say it's 2 over 1, but that's the same thing. So for every 1 unit I go to the right, I have to go up 2 units, right? So if I stop from this point here and I go right, let's say this one. If I go right 1, I have to go up 2. That's what this means. All right, and you can see the second one, the same kind of stuff, and in this case the slope still is positive. And the third one, same thing. But in this case, the slope is negative. Now notice that when the slope is positive, when you go from left to right, the line rises. And when the slope is negative and you go from left to right, the line falls. So negative slope indicates that the line falls from left to right, and positive means the line rises. So here are 3 more examples. Here in this example, when we find the slope, we figure the slope is 0. Well, 0 slope means that there is no change in y. As you change x, y doesn't change, it stays the same. So that means the line is horizontal. All right, the second one, in this case, the slope is undefined because the line is vertical. So the line is undefined. And the third one, well, here the slope is negative 40. Well, it looks like the line is vertical, but that is just because we can't really tell the difference. It's so steep that we can't tell that this is actually a negative slope, but it's a very steep negative slope that looks like a vertical line. So you can't just go by your eyes. You can't just eyeball it and figure out what the slope is. You have to actually calculate it. And notice that when we calculate the slope, we get negative 40 right here. All right. So we use the Greek letter delta for change. So you might see a formula like this for slope that says m equals to delta y over delta x. Delta means change. So delta y is change in x, change in y, and delta x is change in x. So, and slope, of course, we already talked about this. Slope is a rate. So it's used in many application problems in real world. So here is one. Suppose that 2 separate temperature readings were taken at 6 a.m. and at 10 a.m. At 6 a.m. the temperature was 24 degrees and at 10 a.m. was 32 degrees. Now it says find the slope of the line containing the 2 points. Well, here 6 is 6 o'clock. If you assume 6 is 6 a.m., 10 is 2 hours later. So at 6 was 24, at 10 is 32. So when we find the slope, in this case, the slope actually means something. What does the slope mean? Well, the slope means that for every 4 hours, right, every 4 hours of change of time, the temperature has gone up 8 units. Or if you simplify it, you get 2 over 1 means for every hour the temperature has gone up 2 degrees. So you can say the temperature is increasing 2 degrees per hour. So it's a very useful idea in many application problems. Interpret your answer to the first part in terms of temperature and time. Well, we just talked about this. It meant that the temperature has gone up. With what rate? 2 degrees Fahrenheit per hour. And the slope is positive, so we say that it's increasing. So the temperature is increasing at a rate of 2 degrees Fahrenheit per hour. Suppose 2 separate temperature readings, or we did that already, so predict the temperature at noon. So if we assume that the temperature is going up at the same rate, what would the temperature be at noon? Well, how many hours is from, if we assume it's the same thing? So noon is 2 hours after 10 a.m., assuming the temperature increases 2 degrees per hour, and in 2 hours, well, it increases 4 degrees, right? So that means temperature at 10 a.m. was 32. So at noon, you expect it to be 36. It's 4 degrees more. 2 degrees per hour, right? All right. So using the concept of slope, now we can talk about equation for a line. How do you represent an equation for a line in algebra? Well, we can think of a line as having slope and going through a point. So we're looking for a line that goes through a given point and has a given slope, right? So we can think of all the points in the plane that if you connect them to this point, then they have a slope of m. Now we're going to let this point be xy. That means it could be anywhere in the plane, right? And then this point, we're going to fix it. So x sub 0, y sub 0 is fixed in place in the coordinate plane. We don't move it. It's in one place. Now we're going to write an equation for the slope of a line that goes through a point, just a given point, and this point. And we want that to be m. So we write m equals to y minus y sub 0 over x minus x sub 0. And that's the slope. That's it. That is the equation of a line in algebra. But of course, we don't like the fraction form of it. So what do? We multiply both sides by x minus x sub 0. And we're going to end up with this. If you multiply both sides by x minus x sub 0, that's what we get. And then a little bit of, distribution here, and then rearranging. We get y minus y sub 0 equals to m times x minus x sub 0. You might have seen this as y minus y1 is m times x minus x1. That's the same thing. We just call this, instead of x sub 0, y sub 0, we can call it x sub 1, y sub 1. That's the same thing. So that's the equation of a line that goes through the point x1, y1 and has a slope of m. That's how we write equations for a line. And this form is called the point slope form because it has the slope and of course has a point, which is x1, y1. So we call it point slope form of a line. So let's look at an example. Write the equation of the line containing the point that and that. So we got 2 points. We don't have the slope, but we can find the slope. What's the slope that goes through 2 points? You should be able to find that quickly. The slope is negative 2/3. So we're looking for a line that has kind of a slope of negative and goes through both of these points. So we can pick one of them to be x1, y1. Doesn't matter which one. We got 2 choices. So now we have m, and now we need x1, y1. We can choose this one to be x1, y1, right? And if we do that, so this would be the equation, right? And we can simplify it and write it this way, right? So here, y sub 0, we assume this one is x sub 0, y sub 0. So y sub 0 is 3, and x sub 0 is negative 1. We're going to substitute these in the right places, right? That goes way over there. So now y minus 3 equals to negative 2/3, which is m. This one over here and this one over there. And then x minus minus 1. Remember, there is a minus in the formula. We have to keep that. And x minus minus 1 is x plus 1. So we get this equation. And if you do the distribution here and move the 3 to the other side, we end up with, we want to move the 3 to this side, it would be plus 3. And 3 with the denominator of 3 would be 9 over 3, right? If you give it the same denominator. 9 over 3 plus negative 2 over 3 is 7 over 3. Now that last form right here is called slope-intercept form.